Directive Number 1. Training Modules for Interstellar Exploration. Module 7. Advanced Planetary Survey and Resource Assessment. Module 7 focuses on equipping crew members with the skills, knowledge, and tools necessary to conduct detailed planetary surveys and assess potential resources. This module ensures that missions can accurately determine the viability of a planet for exploration, settlement, or resource extraction while adhering to ethical guidelines and minimizing environmental impact. Objectives of Module 7. 1. Planetary Analysis. Train crew members to evaluate planetary environments, including climate, terrain, and atmospheric composition. 2. Resource Identification. Develop skills to detect and analyze mineral, chemical, and biological resources. 3. Ecosystem Impact Assessment. Assess the potential effects of human activity on planetary ecosystems and prioritize sustainability. 4. Safety and Containment Protocols. Ensure crew safety during exploration and implement measures to avoid contaminating the planetary environment or Earth upon return. Module Structure. Module 7 is divided into 6 comprehensive sections, each addressing a critical aspect of planetary surveying and resource assessment. Section 1. Fundamentals of Planetary Surveying. This section introduces the basic principles and methods of planetary surveys. Key topics. Survey planning and execution. Develop a structured approach to surveying, including pre-mission research, in situ exploration, and post-mission analysis. Geospatial mapping techniques. Learn to create detailed maps of planetary surfaces using drones, satellites, and ground-based instruments. Understand the use of topographical, geological, and hydrological data in mapping. Survey equipment. Familiarize yourself with tools like spectrometers, ground-penetrating radar, seismic sensors, and drone technology. Section 2. Atmospheric and Climate Analysis. This section focuses on evaluating a planet's atmosphere and climate to determine its habitability and potential hazards. Key topics. Atmospheric composition. Analyze levels of oxygen, nitrogen, carbon dioxide, and other gases. Detect harmful elements, such as toxic compounds or high levels of radiation. Weather and climate patterns. Study planetary weather systems and identify potential challenges, such as extreme storms or rapid climate changes. Radiation levels. Measure background radiation and determine the planet's ability to shield against cosmic rays. Section 3. Geological and Mineralogical Surveys. This section covers the methods used to study a planet's geological structures and identify valuable resources. Key topics. Rock and soil analysis. Collect and examine samples to identify the composition of the planet's crust. Evaluate the potential for agriculture or construction using native soils. Mineral resources. Detect and analyze rare earth elements, metals, and other valuable minerals. Assess the potential for mining operations while minimizing environmental damage. Tectonic activity. Study seismic patterns to understand geological stability. Identify active fault lines, volcanic activity, and other potential hazards. Section 4. Biological Surveys and Ecosystem Studies. This section emphasizes the study of alien ecosystems and their compatibility with human life. Key topics. Biological sampling techniques. Safely collect and analyze alien flora and fauna without causing harm to ecosystems or contaminating the crew. Ecosystem interactions. Study the relationships between organisms and their environment to understand the planet's ecological balance. Microbial life. Detect and analyze microorganisms, including potential pathogens, and assess their impact on humans and other organisms. Section 5. Ethical and Environmental Considerations. This section ensures crew members adhere to ethical guidelines and sustainability principles during planetary surveys. Key topics. Non-interference policies. Avoid actions that could disrupt alien ecosystems or societies. Prioritize the preservation of the planet's natural state. Sustainable resource utilization. Develop strategies for responsible resource extraction that minimizes long-term ecological damage. Cultural sensitivity. Ensure surveys respect the values and traditions of any alien civilizations encountered. Section 6. Advanced Survey Simulations. This section provides hands-on experience through realistic simulations of planetary exploration and resource assessment. Key activities. Virtual survey missions. Use advanced simulation systems to practice surveying alien planets in various scenarios. Resource mapping exercises. Identify and map resources using simulated drone and satellite data. Ecosystem impact scenarios. Analyze the environmental impact of hypothetical human activities on alien planets. Training methodologies. Module 7 employs a combination of theoretical instruction, practical exercises, and simulated missions to ensure trainees are fully prepared for real-world planetary surveys. 1. Field simulations. Conduct mock surveys in controlled environments that mimic alien terrains. 2. AI-assisted analysis. Use AI systems to interpret complex data and provide real-time feedback during surveys. 3. Collaborative missions. Work in teams to simulate the collaborative nature of interstellar exploration. 4. Case studies. Analyze historical data from past surveys to understand best practices and common challenges. Evaluation and certification. Trainees are evaluated through a series of assessments designed to test their knowledge and skills. Survey planning and execution tests. Demonstrate the ability to plan and conduct comprehensive planetary surveys. Resource identification challenges. Accurately identify and analyze resources in simulated scenarios. Ethical decision-making scenarios. Resolve complex ethical dilemmas involving planetary exploration. Simulated missions. Successfully complete a multi-phase simulated planetary survey, including data collection, analysis, and reporting. Certification is granted to trainees who demonstrate proficiency in all aspects of planetary surveying and resource assessment, ensuring they are fully prepared to contribute to humanity's interstellar missions. Conclusion. Module 7. Advanced Planetary Survey and Resource Assessment equips crew members with the skills and knowledge to safely and responsibly explore alien planets. By mastering these techniques, humanity can expand its understanding of the universe while upholding the values of respect, sustainability, and ethical responsibility. Dr. Ong Der EDF